Today I will be showing you how to solve three integer sum or three sum problem on Leetcode. The whole premise of the problem is we have been given an input array nums which has a bunch of integers in it, and our output should be the three values when added up that sum up to be 0. So for example, we have -1 plus -1 plus 2. So the sum is 0. So this should be in our output. This is one pair that should be in our output, and then the second pair inside this list should be, if you think about it, -1 plus -1, oops, -1 plus -1 plus 0 will also add up to be 0. So these are our two pairs that would give our sum 0, and it doesn't really matter in which order we return the output in, as long as it matches the, as long as it gives our value of 0. So to solve this problem, the most common approach and the most optimal approach is obviously the two-pointer approach. What we can do is we can have, instead of having, think of like 3 pointers. We can initialize 3 pointers. We can have I at the very first index, and then we can have our left and right over here, and then we can just say we can add left and right plus our I and check to see if these three numbers add up to be 0 or not. And we can just say if they do not, then we can just iterate or decrement our left and right to essentially get our 0. And we can also have like a bunch of if statements in the beginning of our loop, saying that, hey, if the number at I is bigger than 0, then essentially we can't find a pair. Oh, sorry, before I begin, we also have to like sort the array. So let me just solve this problem step by step, and I'll explain step by step. So what we need to do is, first we need to like sort our array. So nums.sort. Why we sort an array will become seemingly more clear as I solve the problem, but for now it just makes our problem way easier to handle. And now we can also have an answer array, which will be just an empty array, and then we can say for I in range length nums. So this was essentially like iterate over the indexes, and then we can say, now this will make more sense why we sorted our array in the beginning. If number or nums at I is bigger than 0, we essentially just break our loop. And why do we do that? Because if our number at the very first index is bigger than 0, then no matter what numbers come after it, we would never find our 0. Because as you can see, we sorted our array, right? And if the very first element in our array starts at 1, then we know that we can't have a -1 because we sorted our array. So it will be just 3, like something like this, and these won't add up to be 0. So we have to, that's why we use nums.sort. Hope that makes sense. And we can also have another if condition, and we also don't want to reuse our I, right? So what we can do is we can also have an if condition saying like, hey, if the number at I is equals to number at I minus 1, I want you to continue. So what we're saying essentially here, when we go to the next iteration, and if the number at the next iteration is the same, like for example 1 and then 1 and then 2, like if our list was something like this, or -1, sorry, -1, essentially like something like this. If our list was something like this, we don't want to like reuse -1 again because we used it at I already, right? So we can say like, hey, if the number at if in the second iteration, if number at I matches the number at the previous number that we encountered, we just continue. But there's a problem with this. What if we're like at the very starting index? Then what? We just like go our loop, like essentially our whole code will like break. So we can also add here like if I is bigger than 0, and nums at I equal I minus 1, we can just continue. So continue, right? That's what we can say. Now we can initialize our 2 pointers, which would be at left and right. Our left would be at, let me do something like this. So left would be at I plus 1, and then our right would be at length of nums -1. So why do we say left is like I plus 1? Because remember, like, let me just use an example right here. So we have our list, something like -1, 0, 1, 2, -1, -4. All right. And we have our I here, right? So this is like a fixed position because with I we can find multiple pairs of values that add up to be 0. So that's what we're essentially doing. And we have our left here and we have our right here. So we're saying like I is here, we say L is I plus 1. So L is right here and R is right here. And before I begin solving this problem again, I want you to really understand the concept behind 2 sum 2, because if you don't really know that, then I don't think you should be solving this problem in all honesty. So I really want you to understand like 2 sum 2. All right, so once we have done initialize this, essentially what we can say like while L is smaller than R, sum 3 is equals to nums at I plus nums at L plus nums at R, right? And then we can say if sum 3 equals 0 and dot append nums at I, nums at L, and then nums at R. So yeah, so we're saying like while our L is smaller than R, sum 3, a local variable inside our while loop, is equals to nums at I -1, nums at L 0, and nums at R is equals to 0. We just append. In this case, obviously that's not the case. In this particular case, our output would be -1, -5. So that would be our like final output for like these three values essentially. So what we can do, like we can just say if we have found it, like L plus equal 1 and R minus equal 1. If we don't find it, that is, or if we find it, we also need to like increment an R, L and R, so we can keep finding different pairs as well, right? And we can say if L is smaller than, I mean, sum 3 is smaller than our 0, then L plus equal 1. Why do we say that? So let's say our sum was like, in this case was like -1. So if we were to decrement our R integer, we would just like get further away from achieving our sum of 0, right? So we essentially just say like we increment L, and we can also say like else R minus equal 1. So if our sum 3 is bigger than 0, then we decrement our right pointer because the list is sorted, and essentially we want to reach our 0. So if we were to like increment our L again, we would get further away, right? And in this if statement, this is like the whole skeleton of the problem. In this if statement, we also have to like check for duplicates, that we make sure that we're not reusing our duplicates, right? So we can say while L is smaller than R and nums at L equal nums at L minus 1, L plus equal 1, and we can do the same for our right pointer. We can say while R is well L is smaller than R and nums at R equal nums at R plus 1, R minus equal 1, and we at the end of the loop we just return answer. So this should work. There you go. That worked.